on coding screen. So let me show you. Okay, so what I have done is I have already saved the model files in the form of pickle file format. You can see here. I just have to load this logistic regression model, and in model LR. Similarly, as this model is there, it will be loaded in this variable model SVM. Then simply best random forest model will be loaded into this. So and we will make prediction on same credit card data set. This is the path. Okay, so this is the common practice. As once your model is trained and tested, then you can save it, and then we can use on any data set. Okay, it's a best practice to save the model in keras or any other file format. So okay, you can see. Okay, so yeah, you can see that training data frame is the same data set I told you before, credit card with card numbers.csv. It means this data set is the same data set of this credit card.csv, just we have changed the amounts. So, and I added the card numbers at that time for alert generation. So that's why we are dropping the card number. We don't require this while training the models. And then the training testing part, we have done 80-20 split. You can see test size is 0.2. I mean 20%. Then automatically training size will be 80%. So it's up to you, 70-30, 80-20. You can take anything. Then you have to pre-processing steps. You have to scale the amount and time frame. After scaling that and changing the amount and time, we can drop the time column also. So it we have to do, because we have to transform the data and scale the data while making predictions. So random forest classifier, logistic regression, and support vector classifier will be used. And remember, if if your model is still not performing well, and then you need to add check for sampling techniques also, or you have to add synthetic data. Like in our NN model, we need more data so that these neural networks can understand. But these are machine learning models. Let's see how they will perform. Okay, so what I will do, I will just run the code in which I have already loaded. I have already saved the model files like this I have told you, and this will be loaded and prediction will be made on the credit card dataset. Let me just run this code. Okay, so I have just run this code. It will run. The system is little bit occupied, but you can see, yeah. So the all predictions are gone. It means it has started running, and it will give the results uh, in a few moments. You can see here, this kernel becomes black. It says it's busy. Okay, all right, and you can see the time bar over here also. It's running. It means this cell having code is running now. Let's wait and watch the results. This is a live scenario that I am showing you with all three models. We will make predictions, and we will check how correctly they have identified the fraud and not fraud cases, transactions, I mean. Okay. Okay, so you can see, wow, we have the results with us, and you can see confusion matrix has been built for random forest. Oh wow, what can you see? Can you believe it? 98 and 97 is the precision recall rate. It means the, as I told you, 97% cases has been matched with the earlier fraud cases. It means for 76 cases is our true positives that has been matched with the last previous fraud cases of 492, and even you can say that precision is 98%. It means we have very less false positive. You can see over here only 8 is the count, and 98, 97. This is absolutely out of the box. I mean, this is excellent performance by Random Forest. I told you already that it's a ensemble method, and the lot of decision trees are used, so that's why they are able to find the pattern, and they have done it. But let's see about the confusion matrix for logistic regression. You can see here precision rate is quite good, 88, but recall rate is 62. But our requirement is above 90, but it has underperformed. Though recall rate is less, but 88%, it means for false positive is only 12%. So still, random forest is the one, and still we are waiting for the third one. That is our support vector classifier. The results are yet to come because code is still running. You can see here. Just we have to wait for that. Oh, okay. So wow, we can use this live now. The last results for support vector machine is now here. Okay, so I told you, yeah, it took ample time, because I told you for large data sets, SVM support vector classifier is not, good fit. You can use linear SVC, but I have already trained and saved the model file. That's why I have used. So we can now interpret the results. See, I told you random forest 98, 97 best model, excellent results, outperformed every other model. See, 98% precision, 97% recall, 476 out of 492 cases correctly predicted, just 8 wrong results. And for not fraud cases, 284307 out of 284315 correctly predicted, only 16 wrong. So when we look at logistic regression, you can see 88% precision rate and recall rate is 62. So you can say that it has poorly performed. So you can see here only 306 cases are being recalled out of 492, and even it means even 12% is also the false positive rate. So this is not expected. We are looking for at least above 90. So see, you will similarly see confusion matrix for support vector machine. I mean support vector classifier. In our case, we have taken. So it has very poorly performed. Even though recall rate is 95%, you can see, but precision rate is only 45%. See, 469 has been matched with the 492 fraud cases, but can you believe it? 578 are false positive. They have disposed as fraud, but they are not fraud. That's why the recall rate is above. So we need, I told you, we need precision recall to be balanced nearby 2-3%. It's okay. Like here in random forest 98, 97, just 1% difference, and we this is our best model. So we don't have to look for these other two models, and we don't have to fine tune the random forest model because it have given extraordinary results. I told you it's an ensemble method. Multiple decision trees are used, but still I will show you some fine tuning, parameters, general fine tuning parameters. The parameters are much more. Okay, so here we are on coding screen. So you can see here I have selected model file, that one only, cc2.h5. And what we are doing, we are loading the data frame, same credit card data frame you can see here, and we I have given the path, and again transform the data and make prediction. But what we are doing over here, we are taking the default threshold as zero point 0.5, which is by default in every model. And I will tell you what is the importance of this. Okay, so firstly we will check what is the outcome with threshold zero point 0.5. Means if a model will predict the probabilities, then when we classify them as fraud and not fraud, the transactions above then 0.5 means 50% probability will be fraud, and less than that will be not fraud. Okay, so I will hit the run button now, and the code will run and give the same confusion matrix and classification report as we checked for random forest. So it started running. You can see here it's a live scenario. Kernel got busy, and even the time bar is there. And I have just placed the confusion matrix or random forest over this code. You can see here 98, 97 is the precision and recall rate. So okay, we will see how this model of last project that I made will work with a threshold of zero point 0.5. Just running. See, the model is compiled the loaded model, and the prediction will be made and showed within a few seconds or a moment. It's a live scenario. And again, I want to tell you that whenever your data set is is large, when you it usually turns a lot of time to run on the local machine, even for training as well, and then testing as well. That as you're seeing that time is being taken, you can always go to cloud. That's the best solution. You can run on GPUs, TPUs. There are and number of configuration you can do over there. So wow, you can see here this one 8901. So the code has started making predictions, and just when this uh, will be completed, and it will publish the classification confusion matrix and classification report. It is just the estimated time that is being running per step. Okay, so we are very close now. Just in a few seconds we will show you the predictions and results for the same credit card data set. Okay, so here are the results. Okay, all right. So you can see here again 97 is the recall rate, but precision rate is very bad, 57%. I told you because it is a lot of false positive, 363. So it means precision rate is 57. It means opposite of that minus 100 minus 57 43 something is percent 43% is false positive. So the model has performed badly. It means there it is usually I mean predicting more fraud cases, rather than not fraud, and it is making mistakes in making in recognizing the fraud pattern. So that's why because I have taken the threshold of zero point 0.5, mine's 50%. And what I told you 2 3 minutes back before running this code, that this model, my model CC2 was trained on synthetic data. So it has very high accuracy of we showed the accuracy of 99% something, more than 99%. So what we have to do, this is where we have to give the threshold as per our testing and training accuracy. If I make this 0.99 or just 5% more, it becomes 99.50. Then what happen? I just run the code. now. Okay, just wait and watch. You'll see the code has been running, and you can see here again 8901 steps will be taken. So, and the predictions and the results will be in front of you. It is again running live. Just we have modified the threshold as per our models training and testing accuracy that we have watched earlier. And this is where when you have to adjust the thresholds as per your model performance. This is the main fine tuning. So firstly, I told you the data should be enough. If not, create synthetic data, either by mode, either by GAN models, and then you have to decide the threshold. Okay, just it will just publish the results. Please don't angry on me. It is just coming. Okay. All right. Wow, what a beauty. See, the recall rate is 96% and precision has increased. You can see here from 53 something. I don't know what it was. It has gone towards 74. Okay. So this is still we know that we have to improve this. We have to improve this because we have to beat the random forest model, which is there 98, 97 precision recall rate, outstanding, extraordinary results. So no, bear with me. I will tell you how to fine tune this. I will show you. These ANN models are neural networks. I mean, are firstly I will tell you that random forest is just an algorithm. It is based on decision trees, and these ANN models, they are neural networks. They will mimic like human brain, so they will learn from the data. They are much capable. They are very much capable. I mean, they are capable. Their capability is enormous. Okay, so our that last project model have given 74 and 96 precision recall rate. This time we will check with this fine tuned model how far it has been fine tuned from 74 precision rate and 96 recall rate. Okay, so I have hit the button. The code has started running. You can see here again, same time bar and kernel is occupied. Okay, so this is very interesting that we have saved the model files. I know this should be a common practice with you all, that please save the model files so that it will be easy that you can just use particular model file and the same code. You can like this data set, you can in the same code you will just have our results. In last I will also place these results in the CSV file itself. So we can in Excel we can filter and check there also. So yeah. Oh yeah. So you can see that the steps are being running to complete the prediction and then show the results. Remember 7496 was the last same model, but this is fine tuned model. So how much it has increased? Just wait. Don't angry on me. These things take time. This is totally live scenario, and just because I believe that the audience should know that I'm not making this up. In the earlier in other video also, you can just search on YouTube about the credit card fraud detection. They have shown other another models also, but all of them have just shown accuracies. But I somehow forgot in last project, but I am showing the actual predictions by our ML and ANN models and comparing it with the real fraud versus not fraud cases. So this has not been done by any of them, and some way somehow I am doing it for the audience. Okay, so this model is just about to give the results. Okay, so here are the results. Okay, wow. So the confusion matrix is built and classing report is also published. You can see what is the precision rate 85 and 99. So yeah, oh, wow, what a beauty. From 74 it has been increased to 85. Okay, and 96 to 99. Oh my god, recall rate, is 99%. It means 486 cases has been found out of 492 fraud cases, but still it's a long way to go because 88 false positives are there. I mean, still 85 is the precision rate, then 15% is the this fraud positive, false positive. So we have to reduce that. We have to outperform the random forest model, in which results I have just pasted over here. You can see here 98, 97. I mean 476 six it has found from 492. We have to beat this, and we have to beat this other stats also. Okay, we will not give up, and I will show you now fine tune model 2. Okay, so for fine tune model 2, also again what we have done, that we have defined some class weights from 0 to 1, as you can see, then from 1 to 5 adjust the weight as needed. It will be done automatically. Code will run and will find the best weights, and it will if it find the best weights, it will the early stopping will be triggered and the model will be saved. If early stopping check is there, and with that, when the model will be loaded to the model variable, and then in the end it will be saved into fine tune model 2. So I have already saved that because I have already ran and trained the model. So we will use that. Simply, I will just, as you can see, I have initiated the model, fine tune model 2. I will just run the code, and we will see the results. Okay, so results are about to come. As you know, this is about to complete. All right, just wait and watch. Okay, so you can see here the confusion metrics have been populated, and okay, so we are stuck here again. Fine tune model have the same results like 85, 99 precision recall. We want to beat more, so we are stuck here with fine tune model 1, and again now with fine tune model 2. We are not able to go over 90, even though recall rate is achieved, but due to precision rate stuck at 85 something. uh, we can't give up at this point. So what we will have as per PPT, I will show you ensemble. We will use ensemble learning. I will show you. Just wait. So here we are in types of ensemble learning. As I stated earlier, bagging, boosting, and stacking. But we will use stacking and basic ensemble learning first, then stacking. So let me go to basic ensemble techniques. You can see in the presentation window, voting and averaging we will use, and then after that we will use stacking. Yeah, okay. So I will tell you what stacking is. We will use base models, and you can base model can be either any base model, and then a final model which will learn from the prediction of these base models, and it will give weight to much good prediction, and then will classify the each transaction in our use case of credit card fraud detection. Okay, let's go to the code. Okay, so here we are in coding screen. As you can see that averaging and voting will be performed as I stated earlier. So similarly, same credit card file is there, but please pay attention over here. See model one, but we are loading that our model from last project. Same my model CC2 file that is being trained on synthetic data, and model 2 is our now fine-tuned model, because our both fine-tuned model 1 and 2 are having same result, so you can load either any one of them. So okay, so model 1 this file, model 2 fine-tuned model. And what will we do? First we will do averaging, and averaging will be done. You can see here the prediction of model 1 plus prediction of model 2 divided by 2, simple averaging formula. Then voting will be done. Okay, and for voting you can see here voting prediction 1, voting prediction 2, but we have given threshold, the best threshold that we already have, and then the voting formula will be applied. You can see here predictions are added and divided by 2. uh, initial votings for 1 and 2, and then it will perform the formula. Okay, so let me run this code, and we will see how much time it will take. All right, I'm just running this code. Okay, so you can see I have already run this code. Soon it will start running. uh, yeah, you can see here the kernel got busy and time bar is showing over here. Okay, let's wait and watch for the results. So as I told you, this is the basic ensemble learning method, averaging and voting. After that, we will perform stacking. Calculation techniques will be used for averaging and voting. Just we are about to have results. The two models, one's prediction has been done and saved, and second is just about to make, and then the formulas will take place of averaging and voting. I told you this is the basic ensemble learning methods. So you can see, oh wow, I told you na, that will come in just a moment. Okay, so you can see here 8496 is the precision recall, 471 is averaging classifier has produced, and 89 are still we are struggling with our false positives. Similarly, only similar results with voting. So averaging and voting have not benefited us, so we have to try stacking now. Got, see, averaging and voting have not worked. So last option, we have stacking, and we will see what stacking will do. I have already given the overview of stacking. Let's go to stacking. The code has just will has start running. Yeah, the time bar is there and the kernel is occupied. So we will have our predictions and our results soon. here with threshold of zero point 0.5 for this stacked model. Okay, so yeah, you can see here the results are here only, and you can see, wow, what a beauty! You can see the precision rate for fraud is 96. Can you believe? And the recall, recall rate is 100%. Why? Why? You can see here 491 cases has been identified as fraud by this stacked model. Out of 492, only one case is left, and we have some false positive, that is 22. And that means, only 4% are false positive. Significantly, the this performance has been improved. And you can see from last result was, if I go ahead above, you can see averaging has produced 8496, both averaging and voting. And after 84 and 96, our predict stat model predictions become 96 and 100%. I mean, it's not 100%, 99.99 something, because only one case is not being identified. All 491 other cases are being identified. So can you believe it? I told you stacking works, always works. Okay, let me just apply a custom threshold now. I told you that these ANN models have a very high training and testing accuracies, as I showed you earlier. Why? Because we have given them synthetic data to train upon. So we will use the last threshold, that was 99.5. So I have put threshold is equal to 0.995. Let's just apply this. Okay, so you can see here, yeah, as already the model is built, so it took no time. You can see the we have again improved the performance with reducing the false positive. Earlier it was 22, it become 14 now. Okay, the true positive are same, 495, one is identified, and the rest is same. Just our precision rate from 96 it become 97. Oh wow. So you can see here, we have outperformed the random forest model. That was our goal. If I copy this data of random forest model, if I cut that and paste, okay, okay, here only, yeah. So you can see random forest has given 476 fraud cases out of 492, and our model stack model has produced 491 out of 492. So we have outperformed in terms of true positives. And you can see here, only one is wrong for not fraud cases, and for random forest it has wrong cases of 16, not fraud cases that are wrongly identified at fraud is 16. Okay, so yeah, so our goal is achieved. That firstly, we the first and final goal was to make our model effective, efficient. So that has done with the precision rate of 97, and almost 100% is the recall rate. See, I told you we were struggling with the fine tuning the model of our N model, and we used the techniques, and we fine tuned them, and then we use ensemble learning also, and with averaging and voting didn't turn in our favor, and then stacking was applied, and we got the desired results. I mean, unexpected. I mean, more than expectation. So in this way, you can fine tune your AI model, and there are also precedence of AI model over ML models. See, These ML models, random forest and all, are just algorithms, but they are learning models. I told you that's why we gave them more data, and they was able to find the similarities, and with the help of not a single but double ANN model, and just using their protection and classifying them, we achieve our goal. And one more thing I will tell you, just what is the advancement of these ANN model over ML model. Okay, so I will tell you now what is the advancement of ANN models over the machine learning model, like our random forest model. So you can see here this data. There are some previous fraud patterns in which some features are there, that is amount, frequency, time frame, and merchant. And this is fraud pattern, so the result was fraud. So like in amount, you can see here. Okay, so some amounts are there in fraud transaction or fraud transaction. So last least amount is $50 something. Similarly, some frequency is there, 20 transaction in 1 hour, 15 transaction in 1 hour, and the least is 14 transaction in 1 hour. Similarly, time frames are there, 1 a.m. to 2 a.m., 2 a.m. to 2:30 a.m. Similarly, some merchants are there in which fraud was happened, ABC, NBY, and all. So what happen if new pattern emerges like this? Some fraudsters start using amount of $49, and the least amount in fraud pattern was $50, and then it is using frequency of 10 transaction in 1 hour. Again, similarly, it is going ahead. It is using the time frame of 3 a.m. to 4 a.m. Merchant is also new. So what happens with random forest? Random forest, as I know, told you before, that they are decision trees. So they will ask but whether the amount is in fraud pattern or not. But because the least amount was $50, this is $49. So no, not fraud. So no, I mean the result outcome is no. Similarly, for this uh, frequency, 10 in 1 hour, there is no, there is not present in the frequency previous patterns. So again no. Similarly, time frame is new, that it is not in previous patterns. So again no. So merchant is also not in fraud patterns. So again no. Why? Because random forests rely on historical patterns. Similarly, no will lead to not fraud for this new pattern, new transaction, I mean. And even if they are, I have only taken four features. You can say that if some more features are there, even if majority of random forest is no, then it will lead to not fraud. But what ANN will do, it will if like our model, it was predicting very high probability, let's say 95%. From 95%, if it check amount is is similar with the previous fraud pattern. If no, then it will just cut -5%. Then again, frequency didn't match, -5%. Then again, the time frame didn't match, -5%. Then again, merchant is not in fraud database, then -5%. So initially, from 95% to 75%, it will still give the fraud probability. So we can align the second level alert or report, in which we will cover these transactions. So this cannot happen in random forest. That's it from my side. We have now arrived at the end of this project video, and on a very happy note, we are ending it. As we have achieved a very high precision recall rate, and we have achieved our goal, that to make our model efficient. And we have have outperformed the random forest model. And I told you the advancement of ANN models over ML model. So guys, please take care. So guys and girls, please take care, have fun, and take care. Bye bye. It's Akhil Singh Rawat now signing off.